Okay, cool. We're just getting things set up here. We will get started in a second. Okay, cool. So let's get started. So today, and probably for like the next week or so, I'm going to be continuing work on the static bug finder with the Ghidra script. Particularly right now, what I'm interested in doing is improving the check functionality with, let me go into what exactly I mean by that. So right now I have some checks that can let's say look at a mem copy call, determine that, hey, the size argument is variable and the destination is directly into a stack buffer. What I want to do is I want to modify the checks in such a way that it can actually trace through the function and actually get introspection into where the values are coming from. That way, if let's say you're having like a pointer that is like assigned or has values passed to it, such as a malloc or a stack buffer, it can actually get introspection to like where that is coming from. So let's get started. Let's see, which function do I want to first implement this into? I'd say not mem copy. fgets, yeah, that seems like a good place to check. Start this. However, before I do this, I think it'd be a good idea if I cleaned up the checks a little bit. Effectively, what I want to do is, before I do what I just said, effectively right now, how the method I have is I have it do a check like read variable write check will check if the effectively the size is a variable amount. Read variable write stack check will check if the size is variable and the destination is a stack buffer. What I want to do is I want to effectively modify it because it's effectively doing redundant work with these. Do a check to first see is the size variable, and if so, and then only if that's the case, run this check to see if the destination is also in the stack buffer. And this check right here is where I'll do the actual input tracing. So in order to do this, I'll need to make some changes. How I imagine doing this is I'm going to change this from a void to a boolean. Let's go ahead and run this just to make sure that that works just fine. Okay, oh wait, no, I need to return actual value here. Return false. Basically, if this returns true, that means that the check was actually flagged. If it returns false, it means not. So return false. Let's just go ahead and run this just to make sure it runs just fine. No. Oh, I think this needs to be undercased. Okay, let's try this now. Return, oh, forgot about that. Okay, so that works just fine. Cool, so for read variable write check, this is for fgets. we can have conditional here that's if this is equal to true, then we can go ahead and then run this check, and if it's not, that means that the size is static, and then we can go ahead and run this check, since this check will only be flagged true if the size is a constant value. Okay, cool. We have that ready. Now, also one thing I've been doing here is I finally offloaded a lot of this extra code to a helper function. I'm just going to go ahead and implement that into the read variable rate check, since I'm sort of revamping these checks right now. So for read variable rate check, we can get the calling p code with this. We also need the calling function. Wait, do we only need the calling function? Oh no, we only need the inputs. So we'll need this, and we'll need this. The rest of it we can comment out. Cool, so let's return false there, add that there. Let's have it run. Okay, so that ran just fine, so this effectively works. Now, one thing I will want to do is just add a check here just to make sure that the length of inputs, that the size arg does not extend past the length of inputs. If inputs.length is less than, let's see, if the size is 5, the max input is 4, so we're adding +1, it'll need to be the size minus 2, so less than or equal to size arg minus 2, return false. Let's just make sure this makes sense. If we have an array of 5 elements and we pass in an argument of 3, no, this has to be like this. Minus 2, 5, 3. It only has to be less than, because if you pass in 3, it gets added to 1, that's 4. 4 is the max argument. Okay, yeah, this makes sense. Let's go ahead and run it. Okay, so that worked just fine. Cool. So we have this code right here that will effectively just check if the size to like an fgets or a read call is variable. Next, we have the actual check to see if it's into a static, well, the destination is a static buffer, and let's go ahead and tackle that now. Now, for this, I'm going to revamp it in a way that it will effectively iterate through the entire function. That way, if we have a situation where it is a stack pointer, but the address of the destination to the stack is being stored in a pointer, so when Ghidra looks at it my way, it just looks at the var node and sees it's a pointer in the stack and just doesn't have any idea where it's from. It'll actually get introspection into where this argument is from. So for that, we're actually going to need to iterate through all of the P codes, so you need to retain this code right here. However, Well, we need to slightly modify how it iterates through the P codes, particularly with here. We will need to iterate through all of the P codes of the function, not just the ones associated with the call for fgets, so that's where we remove that argument to get P codes. First, before I get into modifying this, I'm just going to get a good test case to use here. Let's see. Let's go to Phalanx test. GitHub. No, not here. What am I doing? Into fgets. Let's see what's in the first one. Is this a good one? No, that's not a good test case since it is static size. Also static size. Let's see, what about this one? That is a variable size, however, it's not to the stack, so let's try this one. Okay, yeah, this one is perfect. It's a variable size right into a stack buffer. That's exactly what I want. So let's go ahead and import it into this Ghidra project just to make sure that we can work with it. Okay. Also, I see someone just joined. If you have any questions, feel free to ask. I'm effectively just revamping some checks for my static bug finding tool. Okay, cool. So that works. So we have the test case. I'm going to switch it over to process. Since we have it imported, I'm just going to add a print statement here just to verify that we are indeed running this check. If it prints that string, that means it works just fine. Okay, cool. So it is indeed running it. Cool. So we have this checker that's running here. Now now we will need to change how it iterates through. Reason for that being is a lot of basically any any non-trivial binary, there will be jumps in the code path, such as like an if then statement, indirect jump, whatever. And as such, we will need to take into account that while we're iterating through the P codes. Otherwise, we're going to not end up in the same iterating through the P codes the same way that the code flow actually runs through it, and that would lead to some problems with actually trying to trace where variables end up. So, okay, in order to do that, we will need to add a check here for the various P codes that could actually influence the code execution or what's next P code to be executed. So let's pull up. This is a list of all of the Ghidra P codes and the P codes which could influence the next P code to be called. There's branch, there's C branch, there's branch indirect, but that will branch based upon a variable that I'm not sure we know. So for now, let's look at branch and C branch. Location of the next instruction to execute. First, I'm just going to add in an if then statement to just catch these. And we're going to switch this over to if it is equal to a branch. Branch P code. It just occurred to me I will need to write another test case that actually has these P codes in it from the decompilation. That way we can actually check to see if these branching mechanisms are functioning. So this is for a C branch. Let's go ahead and run this. Oh, this needs to be changed. Current P code might not have been initialized. Oh, these need to be below the fetching of the next P code. Let's let it run just to make sure that it functions. Okay, cool. So this is running. What I will want now is I'm going to make a quick test case that just has a conditional in here that this will actually need to deal with. That way I can see this in action. Just going to quickly make the test case. And let's go ahead and do this. So there's going to be, that is going to be the char buff, and this is going to be a pointer. So we're going to have an if then statement. If destination does not equal to 0, then input will be equal to target. And if it is equal to 0, input will be equal to a malloc chunk. And then we'll scan into input. So yeah, as you can see, this is an instance in which this type of input tracing would be helpful, because the way I was doing beforehand, it would only have introspection into input and just see it's a pointer on the stack and not know that it is to a stack value. However, here, if this path executes right here, it would be equal to a value on the, or space on the stack, so that we would be interested in that. So let's go ahead. Oh, I forgot to change it down here. Okay, cool, so that works. Let's go ahead and import it. Okay, let's give it a second to run. Okay, it ran, and we see that it is calling both C branch and branch the P codes. What I'm going to do is I'm going to comment out these. What I actually want to see is I want to see all the P codes in the function, and particularly the branch and the C branch one. That way I can see actually like what we have to reference from the P code itself. Let's go ahead and run this. Also, welcome new people to the stream. If you have questions, feel free to ask them in the chat. This is something did not work here. Oh, I already imported. I need to switch over to process. But yeah, new people to the chat. I'm effectively just working on a Ghidra script to find bugs. We're right now working on data transferring. So we see here the P codes. There's add, load, cast, int equal, which that's effectively, it does a comparison in this condition. This will branch if this var node is a particular value. And here, this branch instruction, is that unconditional? Let's see. This is an absolute jump instruction, so it's always going to jump, and we see that we have here an address. So what we can do here is we can effectively have it so that if we reach a branch instruction, since that will always jump to a particular instruction, we can just jump to whatever all that instruction in the P codes. I'll have to figure out how to do like the address to P code resolution. And then for a conditional branch, since I can either branch, wait, will this only branch one way? This is a conditional branch for the dynamic condition determined by the. Okay, so a conditional branch will either execute this instruction or just move on to the next. So for conditional branches, since realistically our static analyzer doesn't have the introspection needed to know which path it will take, I can just have the iteration go down both paths. That way, effectively, I'll get introspection into either way. Okay. We see people in the chat. I'm gonna respond to them. Okay, cool. So, getting back to this, actually, let me see something. Okay, cool. I was just checking something. Okay, now back to this. Call multi-equal. Okay, cool. How I'm gonna do it? So the first problem I need to tackle is this is a branch to a particular instruction. I need to understand where the P code is for that. So how can we do this? Google. Let's see, Ghidra P code. Let's look at the Java docs for the P code and see if there's, no, that's not it. Okay, yeah, P code up. Let's see, is there anything in here that will help us? Is there like a dot get address? There's dot get output. Dot to string. Set opcode is dead is assignment. There's dot get inputs. Is there any wait? Is there any function that will like we can call and it will give us the address associated with it? I'm not seeing it. Okay, so we don't have that. Actually, is there by chance? I know when I was making reminiscence, I had this problem I solved. I forget how. Let's see. Yeah, it's just branching to a particular address. Maybe we can. So similar to how here we get the P codes for. We can get the P codes for a particular aspect of a function from an address. We might be able to do something similar to that. However, then we only get the P codes for that, and we wouldn't get them further off. Unless if you had some sort of weird like hash map where you had like the index where you can like get the P code associated with an address and then use that to look up what the index is. However, or the other P codes are probably unique enough to do that. However, since there's multiple P codes associated with these, well, that might not be a problem. I was for a second concerned that since there can be multiple P codes associated with a single address, in a weird edge case, it might end up in like a instance where like it can enter into an infinite loop. Since it might be actually no, that shouldn't be a problem. Okay, yeah, I'm not gonna proceed like that's a problem. So for that, how would we want to proceed? Since we're iterating in this instance, we're iterating by the index, no longer the. Actually, yeah. Since you're iterating by the index, we're going to want to enumerate all of them into like some sort of data structure or list, and then go about it that way. Or will we? You know what, I'm just going to start writing code, and let's see if it works or not. First thing is we're going to want to be able to get the inputs or the address that is being referenced. So let's get that, get inputs. For the branch, we're interested in what the function is being called. So inputs 0. And let's have that for C branch. Next, after this, so this is just us getting the address that is being referenced in either the C branch or the branch P code. So we're saying here, let's get var node call address equals inputs 0. Actually, this can definitely be offloaded to a helper function, so I'll do that right now. Public long, since the offset is most always a long. Public long get branch address. It's going to be from a P code. P code op input P code. Okay, cool. So we have this. First thing we're going to need to do here is get the inputs. So input P code dot get inputs. If do we want to do this? No, because it should always be the first one. If inputs dot length is less than 1, return -1. Just a sanity check there, because sometimes Ghidra can do some weird things since decompiling is such a huge problem with a ton of different edge cases. So proceeding, what we're going to want to do next, we're going to get the actual var node branch var node equals inputs of 0. This should be an address, so we just do a sanity check there for that. Dot is address actually, if it is not an address, return -1. So it is an address. I believe I have a helper function like get address from or get offset from address, something like that. Get stack var size. Call site. No, it's just dot get offset. Okay. So let's go back down here. Return branch var node dot get offset. Cool. So we can return that. And that should do it. Let's go ahead and print out the output of that right here. Get branch address, current P code, and let's see if that runs. Nope, forgot a semicolon somewhere. Right, there was a semicolon here. We can just get rid of this code right here. We don't need it. Okay, we see it's printing this value, which in hex is 1011FA, so which, as we can see, that is the address being called there. So we have a helper function to effectively grab the address. That's good. We can do something like long branch address equals get branch address of the current P code. So we have that there. Next up, we're going to need to get the function to effectively resolve an address. Actually, taking a step back, what I'm going to need to do first is, so right now we're iterating through all of the P codes in an iterator. I'm going to need to transition that to like iterate by index, or iterate through the first one, then the second one, then the third one. And then what that's going to allow me to do is I'll be able to call a function here like resolve address to index. So I can like pass it in address and get an index back, and then just set the iterator to that index. That's how I'm wanting to do the like branch or the code flow redirections. So for this, okay, for this we will want to do public. What will I want to do? Well, I would probably want to tackle the iteration problem, so iterating by index first. How am I gonna tackle that? I will, yeah, I'm gonna need to have a function that returns, I'm gonna have a public pcode op array get pcodes, and effectively we'll do this right here. So pcodes equals, what will it take? It will need a reference right there. Need this code here to get the high function associated with the call site. We will then also need to get the p codes associated with it. I wonder, is there like a method for a Java iterator to get size? Okay, so we can, apparently there is like an iterator.size function. Might not be the best way. It might be better to do it as an array list. Okay, cool. So yeah, looking at the time, I've been streaming for about 35 minutes so far, so I'm gonna go ahead and call it good night for tonight. Thanks for watching and see you later.